is a golf term, meaning watch out, something's headed your way. In golf, the set of clubs is designed to cause a specific event, given the ball to travel different distances and different heights, over obstacles or down the fairway. One design element of a golf club is the angle of the club face. Let's consider 3 different triangles representing the club faces for a pair or a collection of golf clubs. In triangle 1, and if you play golf or see any of it, you might know that this might be more of like a driver or some sort of wood that is going to send the ball a long distance. You start getting into your wedges and even like your sand wedge, the steeper the angle is. So what I've done, and please pause the video at any time and write and then come back to it, is I've highlighted, given our scheme for highlighting and marking the sides of a right triangle. From the reference angle, from the reference angle, and from the reference angle, the opposite, hypotenuse, and adjacent sides are marked green, yellow, and orange. Pause, do that, then resume. The reason for the triangles to have those markings because we want to be able to compare their ratios of their sides. And in this lesson, we're going to specifically focus on the ratio of the opposite side to the hypotenuse, or the opposite side to the hypotenuse, or the opposite side to the hypotenuse. So it is also important to label, and you can see that you should be labeling on the triangle theta for your reference angle, then the hypotenuse, then the opposite, and then the adjacent side. And that's what we have here. Question 1, how do you think the club face angle affects the path of the ball? Remember, the ball is going to get smacked by the club and sent. And if you've seen this action, you know a little bit of like physics. The steeper the angle, right? Or maybe not steep. The steeper the angle, the farther out the ball is going to go. The more shallow the angle, the more like slanted that the club face is, the higher the ball is going to go. So club face angle is going to affect the path of the ball. This is for distance, this is for height, and this is for a mix of both. The angle is going to send the ball where you need it to, depending on what sort of score like angle it is. Now they're given numbers instead of like a 27-degree angle or a 21, but serious golfers are paying attention to that angle. For each club face angle, write the ratio of the side length opposite the given ratio, the given acute angle, to the length of the hypotenuse, and write your answers in decimal rounded to the nearest hundredth. By the way, hundredth means 2 decimals. Okay? And then we have to look at the third to see if it's a 5 or greater, to know that we need to go back to the second to round it up 1. We'll see if we get there. Okay, so in the first one, it's going to be opposite side, 19.3, divided by hypotenuse, which is what I'm going to write on these ones. Triangle 1, 19.3 millimeters, divided by 54 millimeters. And I'm writing the millimeters so that you understand these have to be the same units of measurement. We can't mix them up and have millimeters for one and inches for the other. They need to be the same because literally they end up canceling. Then we go to the calculator and we do 19.3 divided by 54. Hey Siri, what's 19.3 divided by 54?
19.3 divided by 54 is approximately 0.3574.
Okay, 0.3574. So we look at the third number, 7, to tell us that the second number, 5, needs to round to 6. And there is our ratio. Triangle 2, opposite side to hypotenuse. So 34.4 millimeters divided by 60 millimeters. And again, the millimeters cancel. But I need to show you that while you're watching this video to know we have to keep the units around, and then eventually you can make the assessment. I'm just going to shortcut and not write them down. But before you make that decision, you got to know that that has to be part of your process. Okay, hey Siri, what's 34.4 divided by 60?
34.4 divided by 60 is approximately...
Okay, 0.573. And then the 3 tells the 7 to stay where it's at, because it's not 5 or greater. The 3 is not 5 or greater. Last one, triangle 3. 39 divided by 62. 39 millimeters, of course, divided by 62 millimeters, of course, and the millimeters cancel because it's a ratio. It actually does not depend on the units of measurement, provided that they're measured consistently. Hey Siri, what's 39 divided by 62?
39 divided by 62 is approximately 0.629.
629, the 9 tells the 2 to become a 3. And again, hundredths, because in the number 100, there's 2 zeros. Hundredths means you need 2 decimals, 2 decimals, 2 decimals after the decimal point. So if you notice that the angle goes from 21 to 35 to 39, these ratios are increasing in size. As the angle measure increases, the ratio of opposite to hypotenuse also increases. That realization, that observation needs to be something that you're processing. And in fact, to be specifically clear, at some point there is a maximum number that the ratio can be. These numbers are all approaching a specific number as we increase the angle measure itself. What that number is, that's for you to explore and continue to develop your understanding on sine. Thanks for watching this video. This has been page 564. Next up, some activities and lessons around the sine ratio in 565. Thanks for liking, commenting, and subscribing. I'll see you in the next episode. Bye.